Singular and non-singular matrices. A square matrix A is said to be singular matrix if the determinant is equal to 0 and it is non-singular when determinant is not equal to 0. So, when we calculate the determinant, if we get the answer equal to 0, then we can say that the given matrix is singular. Okay? So, now let us consider one example. If determinant of if the matrix A 5x 2 minus 10 1 is a singular matrix, then we have to find the value of x. So, it is given, the given matrix is singular, find x. Okay. So, we know from the definition of the singular matrix that a square matrix is singular if the determinant is 0. So, let us find the determinant of this matrix. So, 5x 2 minus 10 1. Okay. This determinant has to be equal to 0 because in the question they have given it is equal, it is a singular matrix. So, let us find the value. So, 5x plus 20 is equal to 0. So, 5x is equal to minus 20. So, x is equal to minus 4. Inverse of a square matrix. Suppose A and B are two square matrices of same order such that the product A into B equal to B into A, and that is equal to the identity matrix or the unit matrix I, then B is said to be the inverse of A. So, we denote B as A inverse. Okay. So, we get therefore A into A inverse is equal to A inverse into A, and that is equal to identity matrix or the unit matrix. Now, from the note that we have verified earlier, we have A into adjoint A is equal to adjoint A into A, and that is equal to determinant of A into I. Now, suppose I divide the determinant, divide this equation throughout by determinant of A, and let us take when determinant of A is not equal to 0, that is when the matrix is a non-singular. Okay. So, let us divide this, we will get A into, okay. So, we are dividing the equation throughout by determinant of A. So, A into adjoint A divided by determinant A is equal to adjoint A by determinant A into A is equal to determinant A into I divided by determinant A, that gets cancelled. So, I will remain. Okay. So, now you see A into this matrix into A is equal to I. It satisfies this equation, correct? Yeah. So, A into, suppose we consider this as A inverse. So, we get A into A inverse is equal to A inverse into A, that is equal to I. So, comparing this equation with this form, we get A inverse is equal to adjoint A divided by determinant A, or you can also write it as 1 by determinant of A into adjoint A. Okay. Now, we have considered the case when determinant of A is not equal to 0 or a non-singular matrix. Okay. Now, suppose if it was equal to 0, then what would happen? I would get divided by 0. So, inverse does not exist. You will get adjoint A divided by 0. Okay. So, that is not defined. So, inverse does not exist in that case. So, for a inverse to exist, the matrix that is given to us has to be non-singular, or in other words, the determinant of the given matrix has to be not equal to 0. Okay. Then only we can find the inverse, and the inverse that we find is unique. So, let us write a note next. A inverse exists only if determinant of A is not equal to 0 and A inverse is unique. Okay. So, for our problems it is enough for us to remember this formula. A inverse is equal to 1 by determinant of A into adjoint of A. If you remember this formula for the problems is enough. Next question, find the inverse of A is equal to 2 minus 1, 3, 2. Okay. So, we have the formula A inverse is equal to 1 by determinant of A into adjoint of A. So, first let us find the value of determinant of A and adjoint of A, then substitute in the formula. Okay. So, determinant of A is equal to 2 into 2 is 4 minus 3 into minus 1 is minus 3. So, we will get plus 3, that is plus 7. Okay. Now, let us find the adjoint of A. Since it is a 2 cross 2 matrix, we know the shortcut to find the adjoint of A. We interchange these terms and change the sign. So, plus 1 minus 3. Okay. Now, let us substitute these values in the formula. So, A inverse is equal to 1 by 7 into adjoint. So, adjoint is 2, 1 minus 3, 2. Okay. So, let us multiply 1 by 7 inside. So, we get 2 by 7, 1 by 7 minus 3 by 7 and 2 by 7 as the answer. Next question, let us find the inverse of a matrix A is equal to a 3 cross 3 matrix 2 0 minus 1, 5 1 0 and 0 1 3. So, we have the formula A inverse is equal to 1 by determinant of A into adjoint of A. So, let us find the determinant first. So, determinant of A is equal to, we will assign the sign plus minus plus. So, that is equal to 2 into, this is 3 minus 0 minus 0 into 0 minus 0, plus into minus is minus. So, minus 1 into 5 minus 0. So, we get 6 minus 5, answer is 1. Okay. Now, let us find the adjoint of A. Now, we know adjoint of A is the cofactor matrix transpose. So, cofactor of A transpose. So, let us find the cofactor matrix. Plus, minus, plus, minus, plus, minus, plus, minus, plus. Let us fill in the determinants. So, we delete the first row and the first column of the matrix A. We have 1 0 1 3, and for the next term we have 5 0 0 3, next 5 1 0 1. Next, let us delete the second row and the first column. We get 0 minus 1 1 3 for the next term, 2 minus 1 0 3, next term 2 0 0 1. The last row, let us cover the last row first column. We get 0 minus 1 1 0, next term 2 minus 1 5 0, last term 2 0 5 1. Okay. And we are taking the transpose of this, so do not forget to write dash or T. Okay. Let us continue. Let us find the value of the adjoint matrix. So, that is equal to, okay. So, this is 3 minus 0 plus 3, this is minus 15, next term plus 5, Next we have 0 plus 1, that becomes minus 1. This is 6. Next term minus 2. Next we have 0 plus 1, so plus 1. Here 0 plus 5 is minus 5. This is 2 minus 0, so we get 2. So we are taking the transpose of this term. So first row becomes the first column. So 3 minus 15, 5. Second row becomes the second column, minus 1, 6 minus 2. Third row becomes the third column, 1 minus 5 and 2. So this is the adjoint of A. Now if we substitute the value of determinant of A, that is 1, and adjoint of A in the formula, we get A inverse is equal to 1 by 1 into this matrix. So 3 minus 1, 1, minus 15, 6 minus 5, 5 minus 2 and 2. Okay. So after multiplying, we get the matrix 3 minus 1, 1, minus 15, 6 minus 5 and 5 minus 2, 2. So this is our answer. Let us consider another problem. Find the inverse of A is equal to the given 3 cross 3 matrix 1, 1, 2, 0, 2, 2 and minus 1, 1, 3. Okay. So we have the formula A inverse is equal to 1 by determinant of A into adjoint of A. So let us find the determinant of A first. Determinant of A is equal to, let us assign the signs. So plus 1 into determinant of 2, 2, 1, 3 minus 1 into determinant of 0, 2, minus 1, 3 plus 2 into determinant of 0, 2, minus 1, 1. Okay. So let us calculate the value. We get, this is 6 minus 4, minus 2, that is 4, minus of 0 plus 2, that will be 2. Here plus 2 into 0 plus 2, that is 4. So we get 4 plus 4, 8, 8 minus 2 is 6. So we got the determinant value equal to 6. Now we will find the adjoint of A. So we already know the formula for adjoint is cofactor matrix transpose. So let us find the cofactor A transpose. Okay. So first I will draw the outline of how my matrix is going to look like. Okay. So plus, minus, plus, minus, plus, minus, plus, minus, plus. Now let us fill in the terms here. So for the first term, we know we have to delete the first row and the first column, fill in the terms. So we have 2, 2, 1, 3. For the next term, 0, 2, minus 1, 3. Next term, 0, 2, minus 1 and 1. Next, delete the second row, first column, we have 1, 2, 1, 3. Next one, 1, 2, minus 1, 3. Next, 1, 1, minus 1, 1. Last row, delete this, 1, 2, 2, 2. The next one, 1, 2, 0, 2. And the last one, we have 1, 1, 0, 2. Now let us calculate the values of the determinants and hence find the cofactor matrix. So we get, this is 6 minus 2 is 4. Next we have 0 plus 2 is 2, but there is a minus sign outside, so minus 2. this becomes 0 plus 2, so plus 2. Here 3 minus 2 is 1, but there is a minus sign outside, so you get minus 1. Next we have 3 plus 2 is 5. Next we have 1 plus 1 is 2. There is a minus sign outside, so minus 2. Here 2 minus 4 is minus 2, minus 2. Okay. Here you have 2 minus 2, here you get 2. Okay. So, we are taking the transpose of this matrix. So, adjoint of A is equal to, first row becomes the first column. So, 4 minus 2, 2. Second row becomes second column. So, minus 1, 5 minus 2. Third row, third column, minus 2 and 2. So, this is the adjoint value. Now, let us substitute the values that we found of determinant and adjoint in the formula. So, A inverse is equal to 1 by determinant of A. So, 1 by determinant of A is 6, 1 by 6 into 4 minus 1 minus 2 minus 2, 5 minus 2, 2 minus 2 and 2. You can either multiply this inside and simplify or stop here. Next question. If A is equal to 3, 7, 2, 5 matrix, matrix B is equal to 6, 8, 7, 9, verify that AB, the whole inverse, is equal to B inverse into A inverse. So, let us first find the left hand side. So, we need A into B first. So, let us find what is A into B. So, AB is equal to 3, 7, 2, 5 into the matrix 6, 8, 7, 9. Okay. So, multiplying this, we get 6 into 3 is 18, okay, plus 49. Next term we have 24 plus 63. Next term we have 12 plus 35. Next we have 16 into 45. Okay. So, let us calculate this. We get 18 into 49 is a 67. Next 87. Next we get 47 and we get 61. So, now let us find the determinant of this. So, determinant of AB is equal to 67 into 61 minus 47 into 87. You will get minus 2 as the answer. Okay. Now, we need the adjoint. So, I will find the adjoint here itself. Adjoint of AB is equal to, we have to interchange these values. So, let us interchange, we get 61 and 67. Change the signs here, minus 87 and minus 47. So, value of AB inverse, that is the left hand side, is equal to 1 by determinant of AB. So, 1 by minus 2 into adjoint of AB. Adjoint of AB is 61 minus 87 minus 47 and 67. Okay. So, this is our left hand side. Okay. Now, let us consider the right hand side. Now, for the right hand side, we need the values of B inverse and A inverse. So, first let us find what is B inverse, then go for A inverse. So, B inverse is 1 by determinant of B into adjoint of B. Okay. So, we have 1 by determinant of B. So, that is 9 into 6 minus 7 into 8, you get minus 2 into adjoint of B. So, interchange the diagonal terms. So, this will be 9, 6, minus 8 and minus 7. Okay. Now similarly, let us find the value of A inverse. So A inverse is 1 by determinant of A into adjoint of A. Okay. So 1 by determinant of A. So we get 5 into 3, 15 minus 14, that is 1 into adjoint. So 5, 3, minus 7 and minus 2. Okay. Now we have to find the product B inverse into A inverse. I will do that here. Okay. So B inverse into A inverse is equal to 1 by minus 2 into, we have 9 minus 8 minus 7, 6 into 5 minus 7 minus 2, 3. Okay. Let us multiply these two matrices. We have 1 by minus 2, this is 9 into 5 minus 8 into minus 2, next term 9 into minus 7 minus 8 into 3, next term we have minus 7 into 5 plus 6 into minus 2, and the last term minus 7 into minus 7 plus 6 into 3. Okay. So when you calculate, you get 1 by minus 2, the value here is 61, this is minus 87, this value is minus 47, and this is 67. Okay. So now let us compare. Now this is our right hand side, correct? Okay. Now let us compare left hand side and right hand side. See these two matrices, they are same. So we can conclude, therefore, AB the whole inverse is equal to B inverse into A inverse.